Members, high five. Density and coins relationships. Members, I'm Fanny Lin. I am from Korea and I am 12.
Joshua Nam. I'm from Korea and I'm 12 too.
Jin Park. I also am from Korea and I am 12.
Table of contents.
Purpose. Observation. We know that the object will float if it's less dense and the object will sink if it's denser. Question. How does the density of different types of liquid affect the time for the coin to fully sink in the different liquids?
Hypothesis. If density increases, then the time it takes for the coin to sink also increases. It is because the density will increase if a mass increases or the volume decreases. Therefore, it will take longer to sink if it has more density than having less density.
Right. Variables. The independent variable is the different liquids and the density of it. The dependent variable is the time for the coin to fully sink in the different liquids. The control variable is the amount of liquid bigger in the coin, which means that they will stay the same.
Material, equipment, method, and safety. These are the material and equipment that we will use while carrying out the experiment and the method we will follow while carrying out the experiment.
Data. Collected data. Water. Water sank really fast and the density is almost 1.
Collected data. Milk. It sinks fast, but not as fast as water. The density is almost 1.
Collected data. Honey. Honey sank really slow. It was higher density than other liquids we measured.
Brief statement. The data shows that the higher the density is, the slower the coin sinks. This might be because of the buoyant force on an item that defies gravity is determined by its density. The closer something's density is to that of water, the slower it sinks.
Evaluation conclusion. Thinking back to the hypothesis, the original predicted hypothesis was that if the density is higher, the time for the coin to sink will increase together. When the density is low, the time for the coin to sink will decrease. The data supports our prediction. This is because from the results, we can see that the higher density, that is the same time it takes for the coin to sink, also increases. But when the density is lower, the time it takes for the coin to sink also decreases.
Validity of method. Strength. The strength in the experiment in the method was that we carried out the experiment 3 times to make it more reliable.
Weaknesses. The weaknesses is that we didn't get the really accurate answer to the experiment. The reason why we couldn't get the exact answer was because we can't get the exact time for the coin to fully drop because it was too fast.
Difficulty. Something that was difficult in carrying out the method was cleaning after the experiment. There were a lot of messy things after the experiment because we used different liquids to carry out the experiments.
Safety, ethical, and social factors. This experiment can be dangerous in several aspects. For example, it might be harmful if vinegar touches our skin. Also, spilling oil on the floor could cause people to slip and fall down. We'll make sure that our experiment runs safe by following rules in the lab while carrying out the experiment and wearing proper lab safety equipment like goggles, gloves, lab coat, etc. We'll make sure that the coins are cleaned after we use them. If we don't, it could cause discomfort to other people who might use them in the future.
How can you apply your results in your everyday life experience? We might drop something valuable in liquid and we need to be aware that by seeing if the density affects the object sinking slower or faster. If the density affects the object, we can be aware that the object is sinking faster or slower in that liquid, so we can pick it up before it's too late.
Resources.
Thanks.